this surface is here to explain the important fact that mere existence of the partial derivative at a point is not enough to guarantee existence of a tangent plane there. So the surface that you see here is of the function fxy equal to minus y. So the axis that you see, which is like this, pointing towards you, that's the x-axis, and the axis that is lying like this, that is the y-axis, and the vertical axis is of course the z-axis. Now this is just a plane, an oblique plane, slanted at a 45-degree angle, and just by looking at it you can understand that this is just a plain smooth thing, so it is differentiable. So let's take a look at the origin, the 0, 0, 0 point, and there it is differentiable. So the tangent plane is the plane that you see, that itself is the tangent plane. Much like if you take a straight line graph y equal to mx plus c, then at any point the tangent is the graph itself because the slope will be m. Similarly here, this is this nice differentiable function. Now what I shall do is, I am going to modify this function slightly. For this, I will take the part of this surface just above the y-axis and going to tilt that like this. So you see, now I get a new surface. When I look at this surface, observe that this surface, so let's just understand what's the equation of this surface. This is same as the last thing. So fxy still remains minus y everywhere else except on the y-axis, which is when x equal to 0. When x equal to 0, I have deliberately made it equal to 0. So this function clearly has both the partial derivatives existing at the origin, because the partial derivative merely looks at the graph along the two axes. So if you start at a point, you merely look at what happens when you move parallel to the two axes. And if you move parallel to any of the axes here, either the x-axis or the y-axis, you will find that you are moving horizontally. So the partial derivative will be 0 both along the y-axis, that is del f by del y is 0, and if you move along the x-axis, that was already 0. So the two partial derivatives exist, and if you consider the plane containing only those two partial derivatives, you will get nothing but the xy plane, which is obviously not the tangent plane. In fact, by modifying this thing in this way, I have made it not differentiable at the origin. So there is no tangent plane.